So the elevator is actually the primary flight control surface that moves the aircraft around the horizontal or lateral axis. This, in turn, causes the nose of the aircraft to pitch up or down. The elevator is hinged to the trailing edge of the horizontal stabilizer and, it typically spans most or all of its width. It's controlled in the cockpit by pushing or pulling the control yoke forward or aft. Light aircraft use a system of control cables and pulleys or push-pull tubes to transfer cockpit inputs to the movement of the elevator. High-performance and large aircraft, on the other hand, typically employ more complex systems. Hydraulic power is commonly used to move the elevator on these aircraft, and, on aircraft equipped with fly-by-wire controls, a combination of electrical and hydraulic power is used. A movable horizontal tail section called a stabilator is a control surface that combines the action of both the horizontal stabilizer and the elevator. Basically, a stabilator is a horizontal stabilizer that can also be rotated about the horizontal axis to affect the pitch of the aircraft. So, a variable incidence stabilizer refers to any horizontal stabilizer in which the angle of incidence of the horizontal stabilizer is adjustable. That means, basically, a stabilator is a variable incidence horizontal stabilizer. There are various mechanisms and operating rigging available for this. Most large aircraft actually use a motorized jack screw to alter the position of the stabilizer, and it's often energized by the trim tab switch on the control yoke. The main reason for a stabilator, or really any horizontal stabilizer variable incidence device, is to minimize drag when trimming the aircraft in flight. You see, deflection of the elevator by using a trim tab causes drag and requires a relatively large elevator on big aircraft to achieve all the desired trim settings. But by varying the angle of the horizontal stabilizer to adjust pitch, less drag is created, and the elevator size and deflection can be reduced. A canard utilizes the concept of two lifting surfaces. It functions as a horizontal stabilizer located in front of the main wings. In effect, the canard is an airfoil, kind of similar to the horizontal surface on a conventional aft tail design. But the difference is that the canard actually creates lift and holds the nose up, as opposed to the aft tail design, which exerts downward force on the tail to prevent the nose from rotating downward. The canard design actually dates back to the pioneer days of aviation, most notably used on the Wright Flyer. Recently, the canard configuration has regained popularity and, is appearing on newer aircraft. Canard designs include two types, one with a horizontal surface about the same size as a normal aft tail design, and the other with a surface of the same approximate size and airfoil shape of the aft-mounted wing, known as a tandem wing configuration. Theoretically, the canard is considered more efficient because using the horizontal surface to help lift the weight of the aircraft should result in less drag for a given amount of lift.